Okay, everybody, can you hear me?
Yes, can hear you just fine.
Okay, great. Uh, Let me share my screen. Can you see my screen?
Yes.
Yeah, just like midterm exam 3 information. Yeah. Okay, so here is again the reminder about your midterm exam 3 that you'll be taking this Friday. This means April 24th. And for the syllabus, you have to look all class lectures starting from 23rd through 30 on 30th means today's class, and try to understand all numerical problems and the homework. And then book chapter covers magnetically coupled circuits, two-port networks, Fourier series application to circuits, and then three-phase circuits. And then you might expect 3 to 4 questions, not more than 4 questions. So uh, what I will be doing on the exam day, around 11 o'clock, I will make the exam available. In the contents tab of the eCourseware, there is a folder like exams. There I will be uploading the midterm exam 3 around 11 o'clock. And then you all need to download it, and you answer your own piece of paper. And then because there will be only 3 to 4 questions, I believe it will not take more than 1 hour. So I hope around 12 or 12:10, you all will be able to finish. And then please proceed with scanning and make a single file and then upload on the Dropbox title Midterm Exam 3 on the assessment tabs. So then you all will be able to upload, I believe, by 12:30. Then you are ready for your next class. So you know that because the duration is short, so that's why I will be asking only 3 to 4 questions so that everybody can answer in 1 hour, and then you can properly upload and scan and upload on the Dropbox. Okay, so oh, and then today I sent out an email regarding your lab quiz, final lab quiz. I think Group 1 has your lab today from 5:30 to 8:15. Um, the lab TA has given me the quiz. It looks like short only. I think there are 4 or 5 short questions that you have to answer. So that's why my thought is that probably it will not take more than 30 minutes to answer. But for today, I will make the quiz paper, that final quiz available under a tab, final quiz, on the content page of the lab section in eCourseware around 5:15 p.m. And then you download it, and then you start writing the answers on your own pieces of paper. And then I am allowing you about 2 hours. I mean, until 7:30 p.m. you could upload it to the Dropbox. Again, the Dropbox title is Final Quiz. Similarly, for the tomorrow's group, Thursday's group, because tomorrow your lab time is 2:30 to 5:15. Accordingly, around 2:15, I will make the final quiz available, and then you download it and start answering. And finally, you have to upload it, the scanned document, by 4:30 p.m. tomorrow. So is this fine? Does anybody have any questions, comments on that lab quiz?
Sounds fine.
Yeah, okay, great. Yeah. I mean, I have allowed you like enough time, I think 2 hours. So I saw the question that Tia had set up. I don't think it will take more than 30 minutes to answer. Okay, so moving forward, today, I mean, it will be the short class. Basically, I set up to practice problems for you regarding the three-phase circuit. And I thought that before I did not cover much about the unbalanced system. That's why today I have set up two problems about unbalanced system that you all need to understand. So you see the problem says the unbalanced Y load of the following figure has balanced voltages of 100 volt and the ACB sequence. This means if you all see this diagram, it's a Y connected load GA, GB, GC, but the phase sequence is ACB. And you see there is a neutral line, neutral point, and in each phase the currents are entering like IA current, IC current, IB current, but then there is a neutral line. Through the neutral line, another current IN is entering and it is going to the point N. Now, everybody will assume that because there is ion current is flowing into the neutral, that also proves that this is an unbalanced system. As I told you before, that if it's a balanced system, then there should not be any current flowing through the neutral. In other words, neutral current is zero for any balanced system. And if there is any unbalanced, then definitely there will be some current flowing through the neutral. That's why in this case, uh, that ion is showing that some unbalanced current is flowing through the neutral. And how the system is unbalanced? It says calculate the line currents and neutral current. Take GA is 15 ohm. This GA impedance is 15. GB is 10 plus J5. You see again the different number, and this is 6 minus Z. Again, this is different number. So as you can remember, our definition of unbalanced or unsymmetrical system was that phase voltages might be the same, but impedances might be unequal. Or it might happen that impedances are equal, but voltage are unequal. In either case, that represents the unbalanced system. So in this case, clearly because GA, GB, and GC are different, so all three phase will have different currents. Voltage might be the same, voltage might be balanced, but the current will be different because impedances are different. That's why this is the unbalanced situation. So in this situation, how can you calculate the current for each phase? So everybody say, uh, because this is Y circuit, this is the neutral point, and this is Y connection. So line current and phase current are the same. So IA is VAN. What is the voltage available across this coil? This means between A point or this point to N. That voltage divided by respective impedance, which is G. And you see on the leftmost side, I have written the phase sequence as ACB. So ACB means because the 100 volt was given. So if you say that VAN here in the diagram, if that is 100 and angle 0 degree, if that is our reference, then because CB is the sequence, so VCN will be minus 120 and VBN will be minus 240, or in other words, plus 120. That's why I have written VAN, VBN, and VCN. Okay, and then now you see the what is the I current? So I current is this voltage across GA divided by GA. So just plug in those numbers. GA value just given 15. So you got 6.67 angle 0 degree. Now similarly, IB and IC, VBN over GB, VCN over GC, that is the IC. And as you can see, the current I has 0 degree, but current IV has 93.44 degree. And then IC has 10 minus 66. As you can see, it is not like 120 degree difference. So that's why current is also unbalanced because impedance unbalanced, accordingly currents are also unbalanced. Now, the other question is, what is the neutral current? So if you all see the diagram, the neutral current is entering into point A. So therefore, according to Kirchhoff's current law, KCL, you know that IN plus IA plus IB plus IC equal to 0. That's why you see I have written for my calculation current in the neutral line is IN equal to minus in parenthesis IA plus IB plus IC. And then you just plug in those numbers that you calculated, IA, IB and IC. And then this is the result. So you can see this means that the neutral has current, 10 ampere current. It's a good amount, significant amount. So if long time this current flows, then that neutral line might be overheated and might be damaged. So that's why unbalanced system is undesired. So everybody understands this problem? Okay, so
Yeah, that makes sense.
It
Yeah.
makes total sense. I was just finishing writing down
Okay,
notes
okay.
on it.
Great. Okay. Then see the next one. In next problem, you will understand the further significance of that unbalanced system, why it is important. Everybody see a three-phase supply with the line voltage 240 volt RMS positively phased has an unbalanced delta connected load as shown in the figure below. Now, and then it says find the phase currents and the total complex power. So when we will be calculating the total complex power, that time you will see the significance of unbalanced system. It is not like the balanced system. So you see the statement says the three-phase supply, the line voltage 240. Line voltage means line to line voltage. So if you see this diagram, delta connected load, again you see first of all, in each phase, the magnitude are different. This is 40 ohm, this is J25 ohm, this is 30 at an angle of 30° ohm. So this means all three phases have different magnitude of impedances. So this means this is the unbalanced system. Now it says, the very first line says the line voltage 240 RMS positively phased. Positively phased means it has positive phase sequence. Not the negative. This is positive sequence. Positive sequence means A, B, C. So in this case, VAB, then VBC, then VCA. So that's why everybody see in the solution, first I have written down the uh, voltage expression of the delta connected load. So VAB is 240 at an angle of 0. So VBC will be minus 120. VCA is plus 120. So this means voltage are balanced because their magnitude same and they're properly 120° phase shift. But the current will be different because the impedances are different. So although those are the line voltage, VAB, VBC, VAC, but you see because this is delta connected load, line to line voltage and the phase voltage are the same. Because if you connect a voltmeter here and here, and then between A and B, it's the same thing. So that's why the current IAB, the question was find the phase currents. You have to find out what current flowing through AB, BC, and C. So IAB is VAB over that respective impedance. So J25. So it gives me 9.6 angle minus 90°. Similarly, IBC is this and ICA is this. You see that all three currents are different in magnitude and the phase angle. Okay, now that what is fine. So now total complex power. Now everybody say what is the significance of unbalanced system? What I have written total complex power. So you cannot multiply by 3 or you cannot use root 3 because this is unbalanced system. So you have to consider phase by phase, one phase at a time. You cannot combine you cannot apply that root 3 VLIL conjugate, or to calculate real power and reactive power, you can say root 3 VLIL cosine theta or root 3 VLIL sine theta. Or even you cannot multiply by 3 the phase voltage and phase current. You can say that, okay, 3 V phase multiplied by I phase, because all three phase has different currents and different impedance. That's why for unbalanced systems, that everybody have to keep in mind. For unbalanced system, you have to calculate power for individual phase and then you sum up those. So that's why here total complex power, complex power definition I have written left side, VI conjugate, VI conjugate. So that's why for phase, for coil AB, VAB multiplied by IAB conjugate plus VBC, IBC conjugate plus VCA, ICA conjugate. And then once again, if it would be balanced system, if it would be balanced load, then what would you write? Just root 3 VL IL conjugate, root 3 VL IL conjugate. And then just you substitute those values. VAB voltage was given and you got IAB, but because IAB conjugate, so you see IAB has minus 90 degree, so I changed to plus 90 degree because you have to make it complex conjugate. Same thing for phase B and phase C. And then you just go phasor algebra. Final result in terms of kVA 3.103 plus J 3.264 kVA. Or you can leave the answer the previous line in volt ampere. So everybody, could you follow me?
Yes, this
Makes
actually
perfect
makes a
sense.
lot of sense.
Yeah. So therefore, I mean, now you answer one thing. If I ask you, okay, please write down the expression of real power for an unbalanced system. So what would you write? Like P equal, you all know that real power for single phase system, P equal to VI cosine of theta, right? And for reactive power, VI sine theta. But like in the previous classes, I think previous, not the two classes back, in three-phase system, I gave you some sort of equation, and three-phase real power expression was root 3 VLIL cosine theta, and reactive power was root 3 VLIL sine theta. But I am asking, okay, if it's an unbalanced system, what will be the expression of real power? Would you still say root 3 VLIL cosine theta? So the answer is no. So what you have to do, like real power equal to VA IA cos theta A plus VB IB cos theta B plus VC IC cos theta C. Do you understand? This means because VI cos theta represents real power, but I am doing phase by phase, and then you sum up all three phases. You can't express like 3 V phase I phase cosine theta because it is unbalanced system. That is the difference. That's why in this case, to calculate total complex power, you are not able to multiply by 3 or root 3. You have to go phase by phase. That's the thing. So therefore, you might expect on very similar questions in the upcoming midterm exam 3 about unbalanced system. Okay, so then today I'll be discussing on important topic. You see here what I have written: 2 wattmeter method for three-phase power measurement. Meaning that we are using only 2 wattmeter to measure three-phase power. I mean, why I am telling this on, for example, just look that previous diagram example, or whatever it is, unbalanced or balanced. So for example, you are asked, okay, measure the three-phase power for this circuit. And you have 1 wattmeter. You know, wattmeter is for measuring the power. So therefore you can connect one wattmeter between coils A and B. You know that wattmeter has two coils. One coils measure the current and other coils measure the voltage. So in that way you need one wattmeter here, you need another wattmeter here, you need another wattmeter here. So therefore simultaneously, in general sense, you need three wattmeter uh, to measure the three phase power, and then you just sum up those three readings. Uh, but what will happen in this case, for example, you can clearly see this point, A point, B point. So the wattmeter has a voltage coil. To measure the voltage, you need 2 points. That is clear, A point, B point. But if it is not available, you see, for example, this is in case, this is inside in box, this is hidden. You are not able to see A, B, and C. And then how would you connect that voltmeter? And it is not clear that it is Y or delta. For example, if this is inside the case or inside the hidden box, and you are not looking it is Y or it is delta. That's why it is not practical or it is difficult to connect a wattmeter in that way. This means what I have written, everybody now read the first bullet. To measure the power in a three-phase circuit load, it is conceivable that a wattmeter can be connected to measure the power in a single phase, and this quantity can be multiplied by 3. So if it's a balance system, then you can just use one wattmeter in a single phase, and then you multiply that reading by 3. That will give you total three-phase power. Or if it is unbalanced system, then you, as I told you, you connect 3 wattmeters in 3 phases and then sum of them. But in the next bullet, I am telling in most practical circuits, however, it is impossible to connect a wattmeter in this manner. Consequently, there is a method called the 2 wattmeter method is generally used. And the connections for this method are shown in figure A in next slide. Now, everybody see Everybody see the on the rightmost side, it's a like Y connected coils. I have given name like H1, H3, H4, so you don't worry about that. It's a coil, it's another coil, it's another coil. This is a three-phase coil, but Y connected. Now, your goal is calculate the total three-phase power for this Y connected circuit. Now, everybody see like W1 and W2. These two basically represents 2 wattmeter. So I am using 1 wattmeter here and I am using another wattmeter here. But that is measuring the total three phase power. So how? You see on the left side, there are 3 lines. Just I have shown on ammeter on online just for an example. So this is online, for example, for phase A. The next line is for phase B. Then this is the phase C. Now everybody see, for example, the top W1 wattmeter. So I believe you all know that wattmeter has 2 coils. You see this letter A is written, on left side letter B is written. This means right side coil, A coil, will measure the current for this phase and B coil will measure the voltage. This means that multiplication of voltage and current will be the power. Now the same thing goes for W2 meter. And you see the connections. This was the line A. There is ammeter though, and then that is connection is going to the current coil, and then the other end of the current coil is connected to a phase. And you see the voltmeter connection. Voltmeter on end is connected to that phase to which you are measuring the power, but other end of the voltmeter is going to a common point. In this case, this is phase B, for example, or line 2. And then if you see the wattmeter, again this line is coming and current is flowing through the current coil, and that is connected to this line, but then voltmeter is connected between this line and then other end is going there. So can you guess why that the voltmeter other end is going to that line? Because To measure the voltage, you need 2 points, right? You all know. You can measure the voltage across 2 points. Now, if you connect your voltmeter one end to this coil, or in this case to this coil, then where would you connect the other point? Because you don't have any neutral line here. This is a Y connection, but there is no neutral line. So if there would be neutral line, then you could connect the other end of the voltmeter to that neutral line. But because neutral is absent in this case, that's why you are measuring the other coil to this common point, this voltmeter, this common point. But this is like phase number 2 or phase B. So because you are making this line as a common point to which you are connecting your voltmeter, that's why this 2 wattmeter indirectly taking into account all 3 phases. And if you are making an experiment and for example you got 100 watt here, 100 watt here, that 100 plus 100, 200 watt, that is the like total 3 phase power. Now to verify that, if you just connect one wattmeter here and again you disconnect, you connect it here, again disconnect, you connect it here, 3 times the reading you will be getting, and if you sum up those, the total power will be the same as this case. That's why it is called, 2 wattmeter method to measure 3 phase power. This is pretty interesting. This means with the help of only 2 wattmeters, you are able to measure the 3 phase power. So therefore, I'm emphasizing this on especially for those who are the computer background, and if you are not on dual major or if you are only a computer major, then definitely you are not going to energy conversion class or other power classes. In that case, this is your only chance to learn this one. That's why, especially for computer guys, I am emphasizing this one. You will be remembering in your real life, like you are working in some company and you need the 3 phase power measurement, then please use only 2 wattmeters in that fashion, and that will be fine. And then you just sum up whatever the reading is, a 200 watt, 200 watt, total 400 watt. That will give you the 3 phase power. Everybody understands?
Yes.
Okay. So therefore, you just simply remember in that way that, okay, 2 wattmeter is measuring 3 phase power. That is the interesting point. And this concept, again, like previous slide, you see the last bullet, the algebraic sum of the 2 wattmeter readings is the total 3 phase power. And it can be shown that this method works for balanced or for unbalanced load. Therefore, the same conclusion true for even balanced and unbalanced system. Just you need 2 wattmeter reading. That will take into account all 3 phases. Because as I showed you that this line is the common, because other end of the voltmeter is connected here. That's indirectly this phase is also getting considered. And this 2 wattmeter is giving you the 3 phase. But as I said, I mean, from general sense, if you just measure what is the voltage and what is the current flowing through this line and you just calculate, and again you use another ammeter and voltmeter here and multiply those and again another reading, and then if you just sum up, still if you just use this method, the result will be the same. That's the beauty of this one. So therefore, with that, today I did not set up any more material because you have the exam on Friday. So therefore, our syllabus is including this slide, and with that, like we are covering the total syllabus for this course. Um, I would recommend you all please try your best to do very good in the midterm exam 3 so that you can cancel your worst one. Many of you have already done well in the second exam. So please try your best to cancel your first exam. Like as I already told multiple times, I will be picking up the best two exam among your 3 midterm exams. For example, you one got 100, you got 90, you one got 80. So your 80 will be cancelled. So I will be making average of your 100 and 90. So it will go in that. Okay, so is there any questions and comments?
I don't
No, it sounds
think
good.
so.
Okay, great.
Need to
So,
study.
yeah, okay. So like I am stop sharing my screen. So and then once again, so I would recommend you also please today's group properly join the lab quiz. And then again tomorrow's group as your scheduled time 2:30 you will be joining your lab quiz. And then I have already created the Dropbox you all will be uploading. Just for today I will be uploading the quiz paper around 5:15. And then, I mean you can be ready at that time, you can see and you can start answering. And then please upload today by 7:30 p.m. the scan copy. And again for like tomorrow the quiz will be available around 2:15, and then immediately you can start answering, and then please upload by 4:30. So I have given you ample time, I think. So you all will be fine. Okay then, so with that, if you don't have any question and comments, so I like to conclude here.
Oh, I do have a question. Not related to this though, related to the project.
Oh, okay.
Are we going to be presenting the project, or should we record a presentation onto the PowerPoint, kind of like how you've done your lectures? Should we do it like that, or should we just make it and then present it? Like, I
Oh
don't know
yeah,
how
you just make the several slides, PowerPoint slides,
Mhm.
and then you just present here.
Okay.
You just share your screen and you present, and then I will be making the recording.
Okay, so it'll be live. Okay, gotcha.
Yeah, it will be live. Right.
Okay, that's what I was wondering, because I was about to start adding voice clips, but I wasn't sure. So I was like, I'll wait and ask you first.
Oh yeah. No, you don't need to add voice. Yeah,
Okay.
because you will be in live. You will be presenting in front of me, and so and everybody can see. And then once you are done, then I am going to upload your presentation on the eCoursera. So everybody has the chance to see each of your lecture.
Awesome. Sounds good. Thank you.
Yeah, and I think I already made a schedule like who will be presenting on 27 and 29, and I'm going to remind you once again. Probably 2 classes back, once I made on slide, and then I think I showed who will be presenting, which group will be presenting on 27 and which group will be presenting 29. But today, soon, I'm going to remind you, and I'm letting you know that schedule. Okay, so is there any other questions and comments from anybody? If not, then I am going to end the meeting now. So everybody, please be ready for the third exam. And I wish you all the best. And also please be safe and have a good day. So see you on Friday.
Thank you, Dr. Ali. Have a good day.
Okay, same to you. Thanks everybody. Bye.